In this video, I'm going to talk about the curve sketching of a hyperbolic function. Well, our hyperbolic function is defined by f of x equals to 2 over x plus 1 plus 2. So now, in order to sketch the hyperbolic function, now the first step is to identify some key characteristics of the hyperbolic function. So now we'll start by identifying the vertical and horizontal asymptotes. So we'll start by identifying the vertical and also horizontal asymptotes. So now let's start by the vertical asymptote. So now for the vertical asymptote of a hyperbolic function, well, the equation of the vertical asymptote of a hyperbolic function is defined by x equals to negative p. So now remember that the standard form of the hyperbolic function, it is f of x equals to a over x plus p plus q, whereby a, p, and q are the constants. So now if we have the function in this form, or let me rather say, if we have the hyperbolic function in this form, then we can identify the vertical and also horizontal asymptotes, the equation for both vertical and horizontal asymptotes. So now let's look at our equation for this hyperbolic function. It says f of x equals to 2 over x plus 1 plus 2. So now it means the equation for our vertical asymptote will be x equals to what? In this case, our p is equals to our positive 1. So therefore, x will be equals to negative 1. So now this is the equation of what? Of our vertical asymptote. So now what do they mean by the vertical asymptote? Well, they mean that our function f will never touch the line x equals to negative 1. So that's what they mean by the vertical asymptote. Now moving on, let's identify the horizontal asymptote. Well, the horizontal asymptote, the equation for the horizontal asymptote is defined by y equals to positive q. So now in this case, what is our q? Well, our q, it is positive 2. Therefore y equals to positive 2, it is our what? It is our horizontal asymptote. So now y equals to 2, it is our horizontal asymptote. X equals to negative 1, it is our vertical asymptote. Now let's move on. So now using these asymptotes, we can determine our range and also our domain. So let's start by determining the domain for this function. Now determining the domain for this function. Well, remember that the domain is the set of all x values whereby our function it is defined. Well, remember earlier I said that our function f will never touch the line x equals to negative 1 and also y equals to positive 2. Now determining the domain, we are going to say our the set of our x values will be the set whereby x it is the element of real numbers and x it is not equals to what? Equals to negative 1. So now this will be our domain. So now we are saying that x will be any real number, but then x will never be what? Will never be equal to negative 1. So now x will be any number besides what? Negative 1. So that's our domain. Now what about range? Range is similar to the domain. So now range for our hyperbolic function. Range for the hyperbolic function will be the set of y values whereby y it is an element of what? real number and y it is not equal to positive 2. So remember when we said that our horizontal asymptote is y equals to 2, we are saying that our function will never touch the line y equals to positive 2. So then our range will be any y value which is a real number, but that y value will never be what equals to positive 2. So now we have identified the asymptotes, the domain and range. Now just like the parabolic function, well, for this hyperbolic function we are also going to determine the x and y intercepts. So now let's start by x-intercept. So now for x-intercept, remember that y equals to what? Y equals to 0. Then we are going to say f of x equals to y, which is equals to 0. Then what is our f of x? F of x is 2 over x plus 1 plus 2 equals to 0. Then now we are solving for what? For x. So now transposing this positive 2 to this side to be negative 2. Then it will be 2 into, divided by x plus 1 equals to negative 2. So this is the same as 2 equals to negative 2 multiplied by x plus 1. So remember that in order to get rid of this function, we are going to multiply by 1 over x plus 1 both sides. We are going to multiply by x plus 1 both sides, not 1 over x plus 1. So now simplifying this will give us negative 2x minus 2. Then transposing this negative 2 to this side, it will give us positive 2 to be 2 plus 2 equals to negative 2, which is 4. Negative 2x. Then dividing both sides by negative 2x. Negative 2. Then x will be equals to what? Negative 2. So now in the coordinate form, our x-intercept it is negative 2 and 0. So now let's determine our y-intercept. So now for y-intercept, remember that for y-intercept x equals to 0. So therefore we are going to say f of 0 equals to 2 over 0 plus 1 plus 2. So now it will be 2 divided by 1, which is 2 plus 2 is equals to 4. Then in a coordinate form, our y-intercept it is 0 and 4. So this is our. Now the last step is to identify key points of the hyperbolic function. While identifying some key points helps us to get a better understanding of the curve's behavior. So now we'll choose a few values of x and calculate the corresponding y values for those x values. Now before we can do that, I've already determined the domain for our hyperbolic function s. Remember that earlier I said the domain it is the set of x values whereby x is an element of what? Real number, and x it is not equals to negative 1. So now identify some key points. From this domain we can choose any x value as long as x it is not equals to negative 1. So now we will exclude the x-intercept. Remember that the x-intercept is whereby x it is equals to negative 2. So now let's choose any x values, any two x values that are not equals to negative 1 and negative 2. Well, I will choose x equals to negative 3 and x equals to 1. So now let's calculate the corresponding y values for these x values. So now let's start by whereby x is equals to -3. F of -3 will be equals to 2 divided by -3 plus 1 plus 2. So now this will be -3 plus 1, which is -2, -2, 2 divided by -2, it is -1, -1 plus 2, it is equals to +1. So now the x coordinate, the coordinates are -3 and +1. So now let's calculate the corresponding y value for x equals to 1. Then it will be f of 1 equals to 2 divided by 1 plus 1 plus 2. So now it will be 1 plus 1, which is equals to 2. 2 divided by 2 is 1 plus 2, it's 3, then it will be 3. The coordinate form, it will be 1 and +3. So now we have some key some key points, and we have identified the asymptotes. Well, let me rewrite the asymptotes. X equals to -1, y equals to +2, then x-intercept it is let me check for, oh yeah, it's -2 and 0. Then the y-intercept, it is 0 and +4, 0 and +4. Then key points. Now these are what we are going to use to sketch our hyperbolic function. Now key points, we had -3 and +1, and we have 1 and +3. So now we are going to use all of these to sketch our function. So now in order to sketch, we are going to sketch our function on the xy plane. So now the one thing that I forgot is to check our value, our a in our function. So now we set that our function, it is defined by f of x equals to 2 over x plus 1 plus 2. So now what is our a here? A, it is equals to 2, which is positive. So now if it is positive, then our function will lie in the first and third quadrant. So yeah. Now let's draw our function. Let's draw a function on our xy plane. So now the first thing is to draw the asymptote. Now suppose this is our -1, then this will be our vertical asymptote. So now vertical asymptote x equals to -1. Then suppose this is 1, 2. Then this will be our horizontal asymptote, y equals to 2. Now let's plot our intercepts, x and y intercepts. We have -2. Suppose this is -2. Obviously this is not drawn to scale, so now this will be our x-intercept, -2 and 0. And let's plot our y-intercept. Our y-intercept, it is 0 and +4. Suppose this is +3 and +4. Now this will be our y-intercept. Now let's plot our key points. We'll start by -3 and 1. Suppose this is -3. Then if we plot this point, this will be our point. Our point, -3 and 1. Now let's plot the last one, which is 1 and +3. hyperbolic. This is our 1, then this will be our point 1 and positive 3. So now what you have to do is we have to join these. We have to join these 2 points. We have to join these 2 points, last ones. And there we have it. Our function f equals to f of x equals to 2 over x plus 1 plus 2. Yeah, and there we have it. We have successfully sketched our hyperbolic function f of x equals to 2 over x plus 1 plus 2. Now, if you have found this video helpful, don't forget to like and subscribe for more more math tutorials, and thanks for watching.